I'm trying to find the area of the track. Now, how would I do that? I have to think about it for a second. I see a couple shapes in here. I see a circle here, a half a circle, and another half a circle to make one circle. I see a big rectangle in the middle, maybe even a small one right here where the grass is. I know some formulas about those. What are those? Let's take a look at our formula bank. For the circle, we know that the circumference is 2 times pi times r. And we also know that the area of a circle is pi times r squared. Maybe we can use those. So what would be the circumference of the circle? Well, the circumference of the entire track is 400 meters. Right here, where the rectangle is 100. The track width, right here, is 16 meters. Maybe if I subtract 100 from here and 100 from there, from the 400, it'll bring that circle together. So, 100, 200. So we got to subtract 200 from 400. That is our circumference of this outer circle here. The circumference equals 400 minus 200, which is 200. Now we can go to our formula bank and plug in C, because we know what C is. We don't know what the radius is, but I'm sure we'll find it out. So now that we know that 200 equals 2 times pi times r. Well, we know everything except for the r. That might be useful information. So if we divide by 2 pi on both sides, we get r, the radius, equaling 100 over pi. An estimated value is 31.84. Great. Now we know the radius, the circumference, but how do we find the area of this entire circle? Let's go to our formula bank. The area, which we want to find out, is equal to pi times r squared. Well, we know what r is, so why don't we just use that formula? So the area of our circle is equal to pi times r squared, which is 31.84 squared. Let's work this out. There we have it. We took pi times 31.84, squared it to get 1013.79 times pi to get our 3,183.28 meters squared. Don't forget your square. But we want to find the area of not the entire circle, but just the track portion. We're going to have to take the bigger circle and subtract it from the smaller circle. Let's do that. So we found the area of the big circle to be 3,183 meters squared. We've also found the radius of that circle to be 31.84 meters. Well, how are we going to find the inner circle so we can subtract it? Well, we know that it has a track width of 16 meters. So all we have to do is take the radius of the big one, subtract 16, and that'll give us our second radius of the small circle. So we have 31.84 minus 16. So our R2 equals 15.84. Now we have something to work with. Now that we have our R2, we can go back to the formula bank and use one of the same formulas all over again. How about area equals pi times r squared? So we'll just use this r and square it. After multiplying by pi, we get our smaller circle, the one on the inside track, to be approximately 787.86 meters squared. Great! Now we have both areas, the larger circle and the smaller circle. So now all we have to do is subtract them. As you can see, we subtract the area of the big circle by the area of the small circle to get approximately 2,395 meters squared. Don't forget your meters squared. We're not quite done yet. We still have this big rectangle in the middle. What do we know about rectangles? What kind of formulas do we know? Let's go back to the formula bank. Rectangles. We know the perimeter is 2 times the width plus the length, and the area of a square is the width times the length. I think those might be useful. Now to get the area of these two different rectangles right here, we have to do some critical thinking. We know that the width right here on the bottom is 100, and we were given the information that the track width right here is 16. So using the formula length times width, this is 160 meters squared, and this is 160 meters squared. Oh, excuse me, 1,600. Bad math. So you add these together, you get 3,200 meters squared. And this is for the rectangles. We're not quite done yet. Now we have to add them together. Ready to find out the area of the entire track? Let's do it. We have 2,395 meters squared, and just add that to 3,200 meters squared. For the entire track, we end up 5,595 meters squared. An extra question, what is the percentage of the track to the entire field? Let's find out. The percentage of the track to the entire field is just the area of the track divided by the area of the entire field. We know the area of the track to be 5,595 meters squared, but what about the entire track? What's all of the area right here? Well, let's do some thinking. We found out the area of the big circle. All we have to do is find out the area of the big rectangle here and add them together. Let's do it. We know the bottom right here is 100, so all we have to do is multiply by this diameter right here. Well, we know that the radius, R1, to be 31.84. That's the radius, but we want to know the diameter, which is twice the radius. Times 100 will give us the area of the entire box in the middle. Two times 31.84 times 100 is 63.68 times 100, which is 6,368 meters squared for the entire area of the large box in the middle. Now let's add that up to the circle. So here we have it. The area of the big circle plus the area of the big rectangle gives us 9,551 meters squared for the entire track. So we know the area of the track to be 5,595. Divide that by 9,551, the area of the entire field, and we get the track is about 56% of the entire field.